So we were discussing in the last session how to what are the important rules when we name these organic compounds. So if we want to separate, the words are separated by numbers with dash, the numbers are separated by commas, and if there are more than two functional group or a side chain are listed in alphabetical order, ignoring di or tri. For example, as you can see, this compound is having bromine and it is also having fluorine. Even though fluorine is attached with the first carbon, whereas bromine is attached with the third carbon. But we give the preference to the alphabetical order, not the numbering here. Like we write them in terms of alphabetical order, the naming is in terms of alphabetical order, even though fluorine is attached with the first carbon. So it will be 3 bromo and 1 fluoropentane. The suffix for alkene can go in front of other suffix. Like example, as you can see, this compound is having two functional group. It is having OH and it is having ene, and there is also bromine is there. So basically three functional groups. So second position we have bromine, so 2 bromo. There are 4 carbon atoms, that's why it is but. The double bond is connected with the first one, that's why it is 3 ene and 1 all. And what about the preference? How we know like which? As you can see, there are 3 functional group. One is OH, another one is alkene, another one is bromo. So what is the level? How we work out the preference level for functional group? So this is how we give the preference order of the priority: carboxylic acid and their derivatives or nitrile, aldehyde, ketone, alcohol, and then amines are there. So if we have alkene or another thing, that is having less priority as compared to that of alcohol. So we give priority to alcohol. As a previous example, you can see that it was having 3 functional groups. It was having bromine, it was having alkene, and it is having alcohol. So when we number, I can number this as first carbon, second, third, fourth. So, or there's also another way I can number. This will be first, second, third, and fourth. So first position we have alkene, then third position, fourth position we will have OH. But if I number from other side, because OH is a priority, so 1, 2, 3, and 4. This is a structural formula given. So OH is attached with the first carbon, bromine is attached with the second carbon, and double bond with the third carbon. So it's 2 bromo, because halogen alkane, the function, their name, we always use a prefix, so 3 bromo. But because of 4 carbon, 3 ene is the position of the double bond, and 1 all because the OH is attached with the first carbon. Is it clear, this example? Any doubt till this point? Then for halogen alkane, the class of halogen alkane, what we do, we use the term fluoro, chloro, bromo, iodo, and give the position. So this is a carbon chain. We have 1, 2, 3, and 4. So second position, we have bromine. So that's why it is 2 bromo butane. But what about alcohols? Alcohol means OH group is there. So again, we give the priority to OH. So when we count, if I count 1, 2, 3, so third position is OH. If I count from left hand side, second position is OH. So we always count from the nearest functional group or a branch, but functional group is given a priority. So but, because 4 carbon, AN, we don't write ANE because this is starting with a vowel. So we don't write E, we'll write only AN. And 2 all, second OH is with the second carbon, that's why it is 2 all. But what will happen if a compound has OH group in addition to another functional group? And whenever carboxylic acid is there, that is given the priority compared to any other functional group. So when we count, when we write the number, we should write in terms of the carboxylic acid. So this is first carbon, second and third. Now the OH is considered as a branch. It's not a functional group for the properties. So whenever we write OH, use as a prefix, then we use the term hydroxy. So second position we have OH. We call 2-hydroxy propane. Prop because of 3 carbon and because they have a single bond. And oic acid is due to this C double bonded with O and OH. Is it clear? This one? If 2 or 3 OH groups are there, so 1, 2, and 3, so prop because of 3 carbon. Now we write A and E. Why we write A and E? Why not N? Because it's a triol, tri starting with letter T, sort of vowel. That's why we write full A and E. And the position of alcohol, that is 1, 2, and 3. Is it clear? These examples of alcohols and halogen alkane? Any doubt? Then how to name aldehyde? For aldehyde, it is C double bonded with ONH, and they're always at the last. And the name should end at AL. So 2 carbon atoms are there at, because aldehyde is starting with a vowel. So that's why it is AN due to the carbon-carbon single bond, and al because of aldehyde. For ketones, the name should end at ONE. 3 carbon atoms are there. So prop because of 3 carbon, and they have single bond in ONE, propanol. But what will happen if 2 are there, and sometime if it is not symmetrical, like example here, this is a symmetrical molecule, both sides it will have the equal number of carbon atoms, but sometime it's not always true that it will always have a symmetry. Sometime it might not have a symmetry. So this will be CH3, CH, and CH3. So if it's not having a symmetry, as you can see, one side of the functional group of C double bonded with O, there are 2 carbon, but the other side there's only 1. So in that case, we have to number this. And again, we number from the nearest functional group. So 1, 2, 3, and 4. Why I did not number from other side? Because if I try to number from the other side, the ketone group will be there with a 3rd carbon. That's why we now follow the numbering where it is closer. So there are 4 carbon atoms. That's why we call that as but. Single bond N. And because the second position we have the functional group, so it is butane, 2 on. 4 carbon, and because they have a single bond, and 2 on because second position we have the ketone. But if it is symmetrical, we don't have to number it, we just write the name directly. Same way, if we have 2 groups of ketone in the same structure, there are 5 carbon atoms, 1, 2, 3, 4, 5. So we can number pent because of 5. Now why we write A and E? Because 2 groups are there, di and tri or tetra. When it is used, it should be the complete name A and E. We do not exclude this E from the name. And second and fourth position we have the ketone. That's why it is 2, 4. So numbers are separated by commas, whereas number and words are separated by dash. But what if we have two functional group like carboxylic and ketone? So again, our priority group is carboxylic. So one, two, three. So second position we have a ketone. So we call that as oxo. That's called an oxo group, and we call it as a prefix. And if it is suffix, then it will be on. So it's 2-oxo propanoic acid. When we name the carboxylic acid, the functional group is C double bonded with O and OH, and the name should end at oic acid. So 3 carbon propanoic acid, here 2 carbon and 2 functional group. So H, because of 2 carbon, A and E, because it's a dioic acid, that's why we use E. So it is ethane dioic acid. If you want to name the nitrile group means C triple bonded with N. So we select, including that carbon in the nitrile, we include that. So 4 carbon atoms are there. So but, single bond between the carbon, and it is A and E. Why? Because it's not starting with a vowel, and because it's a functional group nitrile, uh, C triple bonded with N, it's called nitrile or cyano. So in this case, nitrile group is there. So we write a nitrile. Now, if we have two functional group, one is hydroxy, another one is nitrile. Like OH group is there and C triple bonded with N. The priority group is nitrile group. So we count the number of carbon 1, 2 and 3. So second position we have a branch of carbon and we have alcohol as well, OH. But when OH is considered as a branch, we use the term hydroxy. So 2 hydroxy, 2 methyl. Why 2 hydroxy? Second position we have hydroxy. Second position we have methyl. Prop, because of 3 carbon it is prop. They have a single bond between them, it's N. And nitrile, because of this group we call that as nitrile. So it is 2 hydroxy, 2 methyl propane nitrile. Whereas carboxylic acid and the derivatives like the carboxylic acid derivative, like which can be formed from carboxylic acid, such as esters, acyl chloride, these are known as carboxylic acid derivatives. So if it's an ester C double bonded with O, the part which is attached with oxygen we name it first, and the part which is attached with a carbon chain we name it second. So first position we have carbon, one carbon, it's methyl, and there are 3 carbon in the chain, we call that as prop, and due to this functional group we call that as OH. So it is methyl propanoid. Then acyl chlorides, as you can see, if C double bonded with O and Cl, it's called acyl chloride. So 2 carbon atoms are there at single bond between the carbon atoms, and oil chloride is used for this functional group, whole functional group. Here when we count 1, 2 and 3, so we have a branch. So 2 methyl, 3 carbon prop, single bond N, and oil chloride is due to this functional group. Then this will have 5, because including this 5 carbons, so pent, and because there are 2 groups, functional groups, so it is dioyl chloride, dioyl dichloride, because 2 chlorine are also there, so it's dioyl, the functional group, as well as dichloride. And it is why E and E? A and E is used, E is not removed because it is it's not starting with a vowel. If we have amides, amide means C double bonded with O and N. So 2 carbon atoms are there at single bond N and amide. Then C double bonded with O and N. That's amide group. And that carbon is also having that nitrogen is having 2 carbon attached to it. So in that case, we how to represent? So we use the term letter N, like N is attached with methyl and N is attached with methyl. So NN dimethyl. and 3 carbon, so it is propanamide. Same way, if we have C double bonded with O and N, so methyl group is attached, N-methyl, and 3 carbon, so it will be propanamide. So C double bonded with O, so N and N groups are there, and then there's also another branch. As you can see, so this is one branch which is attached with nitrogen, another branch attached with nitrogen, another branch attached with carbon chain. So N, and this is attached with the second carbon, so it is 2. And how many methyl groups are there? 3, so that's why it is trimethyl. And propanamide, because 3 carbon, that's why it is propanamide. Is it clear, the naming of these hydrocarbons? Any doubt in this naming? So these are the rules which you have to go through time to time so that you can recall. So this is the last part. We'll continue this organic chemistry discussion next session. Any question related to the class today?